Hey guys, so now we're going to move on for part 2 of asymptotes. We're going to look at horizontal asymptotes. So what is a horizontal asymptote? I'm sure that you know in general, but we are going to define them using our newly learned knowledge of limits and such. So the first thing we're going to do is we're going to say, well, what it is if you have the limit as x approaches infinity of a function, okay, and it equals L, where L is a constant, okay, then that's going to give you a horizontal asymptote at y equals L. And of course, the other way that you could get one is the exact same, except that we will approach negative infinity of our function. And if that equals L, that is also a horizontal asymptote. Often it will approach the same L value as it approaches from the left and the right. Not always, but it will often. Okay. So one of the easy things that we can look at here for is end behavior. Okay. So if we have a polynomial function, okay, and it's written out all complicated here, okay, then what we can do is we can just say that that the limits as it approaches infinity, if n is greater than 1 or equal to 1, then the limit, okay, as x approaches infinity for x to the power of n is just going to equal infinity. And it doesn't, there's no more to it than that, okay? It will just always equal infinity, okay? If, however, we're doing the limit as x approaches negative infinity, this will actually make a difference of x of n, okay? So what it will equal infinity if n is even. Okay, and for a simple example, you can just think of a quadratic. If n was equal to 2, then as we go to negative infinity, the line is going up as into wherever, into outer space. Okay? If, however, it is odd, then it's going to equal negative infinity if n is odd. And the easiest example of this is just a linear equation, or alternatively a cubic. Okay, you think about it as we go off to the left, as we go to negative infinity, it's going down to negative infinity. Okay, that's a negative. That is not a well-drawn negative. There we go. Still not well-drawn, but that's okay. All right, now if we have a more complicated one, then let's see. So a polynomial function behaves at infinity as, so in other words, if we've got a big long polynomial like this, the idea is we can actually just ignore most of it. Okay, we can kind of cheat here. We can just say it will do the same thing as x approaching infinity of just the an x to the n. Okay, the rest of it from here on doesn't actually matter. All we really care about is this guy right here when we're finding the n behaviors. Okay, now, okay, before I move on, I'll say then also it works the other way as well. So as x approaches infinity, or sorry, negative infinity. Oh my goodness, I am not doing well with the writing today. Eh? Let's zoom in. There we go. This approaches negative infinity. It will do the same thing. We can just look at the an x to the n. Now, what's important here is this an, okay? The actual number doesn't matter. All that will affect it is the sign, okay? The sign is what matters. Because normally, if it was x squared, then it would approach positive infinity, whether we're going to infinity or to negative infinity. However, if that value out front is negative, it will make it approach negative infinity instead. So the actual value doesn't matter. or looking at the end behaviors of 2x squared is the same as x squared. It's the same as 3x squared. It's the same as 4x squared. But it's not the same as negative 2x squared, okay, or negative 3x squared. All right, so all we really care about there is the sign. So we're just going to quickly do a couple examples here. If we've got x as it approaches infinity, this is an odd function, so it is going to equal infinity, okay? And as I said before, technically that doesn't exist, but we'll just ignore that. So the limit as x approaches infinity of x squared is also just going to equal infinity. Okay, no tricks there. Similarly, x cubed, now we're approaching negative infinity. It's odd, okay? So as we approach negative infinity, this is going to equal negative infinity. And as we approach negative infinity, because this one is even, it is going to equal positive infinity. Okay? So let's just do these ones here. These are a little bit more challenging. And as I say, I am just going to look at this first term, the term with the highest degree. That's the one that matters. And so I can just say, well, it's even, okay? It's even, but it's negative. Okay, so it would approach infinity, but then that negative makes it approach negative infinity. Okay? Over here, we're approaching negative infinity. Again, all we really care about is this term. Specifically, what we need is this negative and this 3 here. So it's an odd function. So as we approach negative infinity, it should go towards negative infinity, but that negative is going to flip it, and so it is going to approach positive infinity. Okay? So that's that for that. All right, so I know what you're thinking. You're thinking, well, let's make this much, much more complicated, and I'd be happy to oblige you. So what we're going to use when you have a more complicated one like this, when you have a big polynomial over another big polynomial, what you're going to use is the fact, and I wrote out all this stuff, and you can actually just ignore that. We're not even going to use that. What we're going to use is we're going to say that the limit as x approaches either positive or negative infinity of the function 1 over x is always equal to 0, okay? As that bottom gets bigger and bigger and bigger and bigger, the whole thing gets closer and closer to 0. And by using that, we can solve these more complicated ones, just sort of using some tricks. So let me zoom in here. And so what we're going to do is first we're going to take a look at the top. And what you're going to do is you're going to take the variable with the highest exponent, and you're going to factor that out, okay? So we can ignore the negative 2. We just say we want to factor out that x cubed. And we say what's left over? Well, we got negative 2, and then we've got plus. And if I factor an x cubed out of an x, I'm going to be left with 1 over x squared, okay? And on the bottom, we'll do the same thing. The biggest one is x cubed again, so we'll factor out an x cubed. And we'll be left with 5 plus, we factor an x cubed from x squared, that'll give us 1 over x. And we factor an x cubed out of 1, and that'll give us 1 over x cubed. Okay. And from there, we can just say, well, hold on. That and that are going to cancel out. As it approaches 0, or infinity, that is going to approach 0, that is going to approach 0, and that is going to approach 0. So all that's left is the negative 2 and the 5. So all we're left with is negative 2 over 5. And that is our answer. So that is our asymptote. That's our horizontal asymptote. As it approaches infinity, it's going to approach negative 2/5. Okay, so let's do a more difficult one here. If we have this, so again, we'll do the same steps. So it's the limit as x approaches infinity. And we're going to factor out the x squared this time because that's the biggest, the highest degree. And we're left with a 3 plus 1 over x squared over, and on the bottom we're going to factor out the x cubed. And so then we have negative 2 plus 3 over x squared. Okay? So, for this one, you notice, unlike the last one, we can't just cancel out this and this, but we can reduce it. Okay, so what we can say is, we can say, well, that's the limit, x approaches infinity, of, and we can use our exponent rules and see that that is just 1 over x. Okay? And then we'll still have all this stuff. We'll have 3 plus 1 over x squared. But we're actually kind of wasting our time because none of this stuff matters. And the reason none of this stuff matters is that this guy right here is equal to 0. And so I'm multiplying the whole thing by 0. And so this just equals 0. And so that is our asymptote. Okay? And finally, this one is a little bit more challenging. Not really. Okay, this one, limit x approaches infinity. Again, we take the biggest one, which is the x to the 4. Whoops. So we'll say x to the 4. We got 3 plus 1 over x squared minus 1 over x cubed over, and now we'll factor out the x squared. Okay. X squared, so we'll have negative negative 1 over x, no, sorry, that's just negative 1. Sorry, I spaced out. Plus 1 over x, right? Yeah. Minus 1 over x squared. Okay. So again, this one, this one, this one, this one, they're all going to equal 0. Okay, now the other thing is we've got an x squared here that can cancel it with that, and that can reduce to a 2. So basically what we're left with, I keep switching to blue by accident. What we're left with is x squared times negative 3. Okay. So, what is that? Oh, nope, that should be that's a 2. That's a 2. There we go. Sorry, so what is that approaching? Well, you've got a negative times x squared. This is approaching infinity. This is negative, so it's going to be approaching negative infinity. Okay? And that's that. Okay? So if you go over to the next page, just at the top, you can just ignore this part. Ignore that. And I want you to attempt these ones before next class. And I'm going to stop here, and we're going to split this into a third video, because 2 wasn't enough. And so we'll do oblique asymptotes in the next one. Thank you very much.